We've done exponential functions with log functions. We've done exponential with trig functions. Let's try this. Look at this combination a little bit closer in depth. What is the antiderivative using integration by parts of e to the x times cosine x dx? How do you want to start? What would u and dv going to have to be here? Good look up, sir. U should be e to the x, okay? So then dv is the other part. Well, that's an easy derivative. The derivative of e to the x is another e to the x dx. What has a derivative of cosine? What is the antiderivative of cosine? Sine inverse. So this should be equal to u times v, e to the x sine x, minus v du minus the antiderivative of e to the x sine x. Like we saw yesterday, what we're going to have to do now. Integration by parts more, right? How do I evaluate this new integral? Hey, I'm sorry, but we got to do integration by parts round 2. So as we did earlier, let's set up another u and dv. U equals dv equals, let's just try the same thing. E to the x sine x dx. So du is another e to the x dx. And v is, what is the antiderivative of sine? The cosine. The derivative of cosine is negative sine. I want it to be positive sine, so that's where the other negative comes in. Another integration by parts. Really got to watch these signs. Easy place to make a sign fit, because now I have to minus whatever I set up for round 2 of integration by parts. I'm going to subtract off this antiderivative of e to the x sine x dx using IDP. So u times v, e to the x times negative cosine x minus v du minus the antiderivative of negative cosine x. Sorry, let's do negative e to the x cosine x, but e to the x first. That's a lot of looking negatives here. Let's clean this up. I see too many negatives for my brain to make sense of this. Double negative here, so see you later, make that positive. I have a negative here, let's just put that out in front. But I'm also subtracting everything originally here from what was negative out in front of the brackets. So let's clean this up. I'm going to bring out e to the x sine x minus negative e to the x cosine x, which is because of the double negative positive e to the x cosine x. This minus the integral of e to the x cosine x dx. I'm subtracting this integral here. Down. Anyone see an issue? I'm in the loop, right? I'm in the loop. Looks like that's what we started with. Our whole goal was to find the antiderivative of e to the x cosine x. That's all we got right here. That's what we're going to do. Any thoughts before I kind of spoil it for you? Give you a hint. Turn it out what you have from the left. Well, this is what it's equal to. What I've done so far is I've shown that through integration by parts, the antiderivative of e to the x cosine x dx is equal to this expression. But I got to solve for my answer. I don't quite have my answer yet. I don't want my answer to be in terms of another integral. Take a look. So start solving for my answer now. Just move this term over to the left. Let's see what that would do. I'm going to add the antiderivative of e to the x cosine x dx to both sides. Because now that cancels out, giving me e to the x sine x plus e to the x cosine x. What do I have over here on the left? Two of those definite intervals, right? Two of those antiderivatives. Two integrals of e to the x cosine x dx. I didn't have. Ever get stuck in a loop, a time loop like that? Trying to figure out what e to the x cosine x dx was. Well, that's just what I started with. I'm kind of stuck in a loop. So add this integral back to the other side, and now you've doubled whatever you're trying to solve for. So just cut it in half. You see your answer. Does that process make sense? Good catch. The integral that's a part of my process here was just the same integral I started with. Just back to the other side. And you double whatever you're trying to look for. Got there. You double whatever you're trying to look for and solve for. So cut it in half and you'll have your answer. The integral of e to the x cosine x dx is 1/2 e to the x sine x plus 1/2 e to the x cosine.